Imagine you have a line and a point outside of it, then imagine a circle tangent to this line and centered at this point with a radius of r, and then cut off anything left from the circle outside of this triangle here. What I'm going to show is that if these two guys, this yellow curve, yellow circle sector, and this white line have the same linear charge density, I'm going to call it lambda, they'll create the same electric field at this point. The electric fields which they create at this point are equal, E2 and E1. So if this angle here is theta, this distance x, radius is r, the electric field which this small yellow piece creates at this point, I'm going to call it dE2, is equal to lambda times r times d theta. R d theta is the length of this piece, so this would be the electric charge of that piece over 4 pi epsilon 0 times the distance, which is r squared. This equals lambda times d theta over 4 pi times epsilon 0 times r. The electric field which this piece, this white piece here, creates at this point, dE1, is lambda times dx over 4 pi epsilon 0 times the distance of this point from this point squared, which is r secant of theta squared. And there's another thing. We know that x is equal to r times tangent of theta. So dx is equal to r times the derivative of tangent of theta, which is secant of theta squared times d theta, r secant theta d theta. So if I replace dx here with this guy, what I would get is that lambda times r secant of theta squared over 4 pi epsilon 0 r squared secant squared of theta. The secant terms cancel out, and this r here cancels out. Oh, the only thing left would be d theta. So then this would be equal to lambda times d theta over 4 pi times epsilon 0 times r. So dE1 and dE2 are the same. And it's obvious from the shape that the direction of the electric field which these two guys create at this point is also the same. So I can write that dE1 is equal to dE2. If I add up all dE1s and all dE2s, integration, the definition of integration, what I would get is that E1 is equal to E2. This is a nice little fact that literally any physics student knows, but I thought it would be fun to make a video about it. That's it. I hope you guys enjoyed it, and see you later.